Welcome, quadrature fans. Today we'll do a continuation on the variation of Johnson Jackson Pythagorean Theorem proof that c squared equals a squared plus b squared. And we've done work previously which needs to be just refreshed a little bit. We're going to use a more trigonometric approach to things. So here we have, these are called, I guess, double angle formulas and angle difference formulas of sine and cosine. And Linda Green, she has an excellent website using this diagram, which I like. So I refer you to her channel, which is below. And also MathyJaphy has an interesting proof for this limiting process, ... It's a geometric series. Interesting. So you could go to it, and he's worked it out nicely. Basically, we're going to have four proofs, four of them actually, four variations, but they're all similar. This 2 alpha angle, we're going to look at it from the sine and the cosine perspective, and this beta minus alpha angle, we'll look at it from the sine and from the cosine perspective. So looking at it from sine perspective, essentially what we're going to do is look at things from this diagram perspective. Sine 2 alpha is opposite u over hypotenuse v. That's if you have a right triangle, you can do that, and this is a right triangle. And so plugging things in, which we have done in my previous videos, here's u and here's v, and now we simply plug that in and calculate, simplify. You got sine 2 theta equals 2ab over b squared plus a squared, which yeah, that kind of looks like this. This is the same thing, right? If you just rearrange sine 2 alpha with this a squared plus b squared, you get the same thing. These and these, that's the same equation. Of course, now we look at things from these sum of sine of a plus b, which is the same thing as this double angle sine 2 alpha, 2 sine alpha cosine alpha, and that is simply looking at it. 2 sine alpha cosine equals 2 sine alpha, 2 times a over c times b over c, because that is the definition of sine and cosine, after all, in our system. That's 2ab over c. And we can get the same thing from the law of sines. Sine 2 alpha is to 2a as sine of beta is to c. That's pretty straightforward, and you crank that through and you get the same results, right? The same thing. And I believe this is how Johnson and Jackson have done it. So now look at these things. Essentially what we have is these two are equal. And look, the numerators are equal, therefore the denominators have to be equal. And this proves that c squared is equal to a squared plus b squared. So you have this equation here is this. And so that's looking at things from the sine 2 alpha. Okay, so now we will look at the cosine of 2 alpha. And that's, again, c over v. That's adjacent over hypotenuse. Which, when you crank things through, we know what v is. It's the same thing as over here. And you crank that through, you get b squared minus a squared over b squared plus a squared. That's from this right angle perspective. And then we look at this from the double angle formula for cosine, which is cosine squared minus sine squared alpha. And in ratio form, that is b squared over c squared minus a squared over c squared, which is b squared minus a squared over c squared. Now notice, these two entities are the same. The numerators are the same. Therefore, the denominators are the same. Therefore, c squared is b squared plus a squared. Okay, now we will do cosine of beta minus alpha. That's this angle. Looking at it, that's u over v. That's the same as sine 2 alpha before. So we've had this. We just leave that up there. It's 2ab over b squared plus a squared. That's from this perspective of the right angle. And then from the difference angle formula, cosine beta minus alpha is cosine beta cosine alpha, sine beta sine alpha. In ratio form, it's AC times BC plus BC times AC. That's 2AB over C squared. Okay, well, you can see that this is the same thing. The numerators are the same. Therefore, the denominators must be the same. C squared is A squared plus B squared. Now, sine beta minus alpha, that's this angle. Well, it's the same as cosine 2 alpha. We've done that already. It's C over V. C over V. Opposite over hypotenuse. And we've done that before. Plug it in. You get b squared minus a squared over b squared plus a squared. That's from this right angle definition. Then from the difference angle formula, sine beta minus alpha is sine beta cosine alpha minus cosine beta sine alpha. In ratio form, that becomes b squared minus a squared, the whole thing over c squared. Notice, these two entities are the same, sine beta over alpha. The numerators are the same. Therefore, the denominators must equal. C squared is equal to a squared plus b squared. And that kind of, summarizes it. Let's just put all of them together at once. You can see all four. There's really four variations of the Johnson Jackson Pythagorean Theorem. I think this is the one that Johnson and Jackson have used. At least that's what I saw on the videos below. I haven't seen their work, but I've seen other people's work, and that's what other people think. So there you have it. We have four flavors, and they're all very similar. They crank the same way. So, all right. See ya.